On this episode, the insiders discuss safety-critical open-source operating systems. Do the rigid requirements of safety-critical embedded applications force users to reduce the flexibility many believe is the biggest advantage of open source? And if so, why not just license a commercial offering? Next, Kate Stewart, Vice President of Dependable Embedded Systems at the Linux Foundation, provides her take on the evolution of embedded operating systems and what does that mean for systems engineering today. Finally, embedded computing design's assistant editor Taryn Engmark gives us the rundown on BrakTooth, a group of security vulnerabilities in more than 1,400 Bluetooth-enabled devices, and what you can do about them.
Hello and welcome to the Embedded Insiders. I'm Brandon Lewis, Editor-in-Chief of Embedded Computing Design, and I'm here with Rich Ness, who's the EVP and Brand Director of the same property. How you doing, Rich?
I'm doing pretty good, thank you. And yourself?
Fantastic. The Phoenix Suns have won 17 consecutive games.
You know, they beat my Nets, and I didn't really look at them until they beat the Nets. And I said, well, if they could beat the Nets, they must be for real. So
if they can beat the Nets, they can beat anybody. And sure enough, the next game we played, we beat the Warriors. So
very good, very good.
So I'll see you when I'm hosting the Larry O'Brien Trophy.
Good for you. What's the latest in the world of embedded systems?
Well, you know, one of the things that has been sort of slowly evolving over time is the embedded operating system space. And one of the newer
slowly evolving over time.
Slowly. I mean, you know, why do you need to, if it ain't broke, don't fix it, right?
Yes, it would certainly give molasses a run for its money.
Yeah, for sure. But one thing that is new is that more recently, companies and organizations like the Linux Foundation have been trying to add more and more embedded capability or embedded-like capabilities to general purpose operating systems like Linux. And that's happened, you know, years ago with real-time variants of Linux. And then more recently, this ELISA version, which is Linux and safety applications. Is Linux, can you use Linux in an embedded application, period? Is that possible?
Absolutely, without question. And I think you said it in reverse. It's not adding things to make it for embedded, it's taking things out to make it for embedded.
Correct.
Because it's so application specific, you just want to hone in on the things that you really need. And if we're talking about security, that I was going to say makes security easier, but nothing makes security easier, but makes it make more sense because you're so streamlined. You have fewer things to watch out for. You have fewer nodes that you have to batten down. So it does make more sense.
Did you just imply that you believe that an open source software can be good from a security perspective?
You know, it's actually funny to say that because I had this conversation with Colin Duggan as part of the presentation he gave at the IoT Device Security Conference a few weeks back. And basically, I don't remember what the title was, but the theme was open source is really good for embedded systems. And I started the webinar by challenging him saying, you're wrong. It's not, it's just too easy to bring bad things into open source. And his comment was, listen to the webinar, let us go through our presentation and see what you think. And frankly, at the end of the webinar, we ran out of time and I didn't have a chance to really give my commentary on that. But it really does make more sense now. I'm not completely a believer yet, but it makes more sense and I'm open to it. If you can get it into the right with the right streamlined, if that's the right word, into your specific application. It's definitely not a one size fits all, and I don't think it ever will be, but it does make more sense.
And I think that circles back to this question of ELISA. So as you said before, you need to take things out to make Linux applicable in embedded use cases, which means streamlining things. But where you start running into problems is, well, you've got to start integrating all of these different things into your build if you're going to use open source and you're going to use Linux. And once you start doing that, the propensity for you to end up doing something that's not really safety critical or not really, addressing everything from all the possible security threat vectors, that's when it becomes a challenge. And frankly, I think that's where my question is what's at the middle there? I mean, the benefit of using open source is that you're free to do what you want with it, and it's a lot more flexible, and in theory, it's cheaper. But you're sort of constraining it in these safety use cases, aren't you?
Yes. It's funny because when I think of Linux, when it first started 100 years ago, it was pretty streamlined, and over time, because it's open source, it got more bloated and it got bigger, and you really wouldn't think of putting it in some of the applications it's in today. But if you want to do it in those safety critical applications, if you really hone it down to just the parts that you need, something like Elisa will likely solve that problem. So
at which point, if you want to use open source and you're going to use something that's to come out of the Elisa project, and you're going to start integrating all your other stacks and file systems, libraries, utilities, what have you, then you are going to have to go get this certed by somebody so that you can use it in whatever your safety critical application is. And that's going to take a lot of time and it's going to cost a lot of money, at which point you probably, or I thought the old you would have said, why not just license a commercial RTOS and be done with all that?
Well, I'm actually thinking, okay, now I'm going the RISC-V route, and I may not be paying nearly as much for my hardware either, and it'll take me a little while. So if I could do this in tandem, it might make sense, because now I'm doing the co-development between the hardware and the software, really making a perfect marriage between the CPU and the RTOS. Hey, I'm getting pretty excited by this.
Well, but I mean, it sounds like it is. Do you really want to make something that is so fit for purpose, like fixed function? You got this incredibly, are you going to go through all of the time and effort and money of, developing IP, producing a chip, and having an operating system that is perfectly tuned to it to be able to sell it to 20, 30, 100 clients only?
Oh, okay. So I'm one step ahead of you. I'm the OEM.
Oh, okay. Yeah, actually, that makes perfect sense. If you're doing it at the application level.
Yeah, somebody's given me $1 million. I'm one step out. I'm already doing the hardware and software co-development.
Okay. Yeah, if you got the time and the money, and it's probably more than $1 million, but if you got the time, why not? If you can do it for, what is it, NLOS? Who are our first clients? where's the $1 million?
Yeah, you got $1 million I could borrow.
I was just gonna say, have you been keeping the $1 million for me?
Next, Kate Stewart, Vice President of Dependable Embedded Systems at the Linux Foundation, discusses the ever-evolving embedded OS landscape.
What would you call an embedded operating system today versus what you would have called it, 10, 20 years ago, versus what you will call it 10, 20 years from now?
I first did my first RTOS back in the 80s as part of my master's program, where we were creating a real-time operating system for a model train set and managing it being controlled around the tracks, and got the first exposure to these types of things then, as well as doing something like a step motor controller, where, when the motor gets warm, the characteristics change, and having to adapt to the characteristics of real hardware and the physical environment is kind of what makes an embedded operating system, in my mind still. And operating systems today like Zephyr, or as well as a variety of the other ones that are out there, are sort of designed for these types of spaces and making some of the common tasks easier, and quite frankly, improving the quality of them rather than something that was hand-coded in bare metal. There's more testing when we can actually share the common load. But, at the end of the day, you're working with software that has to manage a specific device or set of devices, and you want to make sure it's as reliable and dependable as possible. And, in these current days, you want to make sure that your threat, your attack surface is minimized from a security perspective, and any hazard analysis is done from a safety critical perspective.
What do you think about, the interplay of embedded operating systems in these bigger systems that have, multi-use requirements, I guess, integrating enterprise plus control, does that mean we're going to have multiple operating systems? Is one operating system type of operating system going to evolve out of this? What's your take?
Well, Linux, for instance, has had an embedded version of Linux, or embedded considerations in Linux, for the last 20 years. Linux has been around in the embedded space that long, if not longer, possibly, depending on who you talk to. And so the real-time patch set, for instance, has been around for close to that amount of time too. The challenge has been getting these things that have been sort of on the peripheral actually upstream in the mainline. And so real-time Linux project, for instance, has been working over the last 5 years of cleaning up the quality of certain parts and actually upstreaming these patches so they're all mainstream in the kernel. There is getting these things upstreamed in the kernel improves the quality for everyone who's using them, but there's a large range of industrial and applications that are already out there today with Linux. We're seeing Linux being used in all these places already, where there is some degree of need for crisp timing constraints and being able to adhere to these crisp timing constraints, which is what real time really is about. So we've seen Linux already in the embedded Linux space, and in fact, the Embedded Linux Conference has been around for a long time as well. And you find people that really want to focus on these embedded aspects of Linux. And a lot of them actually have gotten, working with Zephyr because, there's a lot of commonality in terms of the, they're both using device tree, they're both using the config information, so you're only bringing in what you need. And making it flexible and modular, is something that in the embedded space is very key. And both, Linux and Zephyr have that capability. So we are, as you say, we're seeing a lot of the general purpose computing functionality being adapted and working in embedded. And all the stuff that's been working on Linux today that's attractive, we're starting to see coming in, like some of the popular abstractions like containers, for instance. I'm seeing people working on how do we work with containers within an embedded context. And so setting up systems that are using virtualization and having, Linux working in certain address spaces and, other RTOSs like Zephyr working in different ones and how they interact. We're starting to see people put these types of configurations together. And then, focusing on a task and having that modularization to have crisp focus on a specific task is playing a role. We're also seeing things like people wanting to do analysis at the very tip of the edge for things like machine learning, like to do recognition, recognition of traffic lights, recognition of, there's some signage coming up, something like that. So being able to add that recognition very close to where the sensors are and the actuators are is driving a lot of machine learning types of techniques down into these edges. And we're seeing a lightweight versions of this technology start to emerge. So people want that functionality, but they also want the, I don't want it to be bigger than it needs to be because I'm going to, every fraction of a penny is important for these devices. And so these resource constrained footprints are wanting to adopt the functionality. And so there's some interesting, system engineering trade-offs that have to happen.
There's always going to be a need for RTOSs. Obviously, I mean, Zephyr's not that, not that long in the tooth. So do you think that those are going to be increasingly marginalized because of the trend towards adding more functionality to these embedded systems? Or do you think that, I mean, take away the fact that, there's always going to be a trillion light bulbs, right? But is the use case going to be increasingly marginalized because you can get more from, a real-time embedded flavor of Linux?
Well, the challenge is that Linux doesn't get much smaller than 2 meg these days. And for the sensors and actuators, you really want something a lot smaller. You just want the functionality you absolutely need available on those devices. And so for things under 2 meg, Zephyr is giving you certain capabilities. And we're thinking things like, a light version of TensorFlow, like TensorFlow Lite being created. Light versions of various environments that are used to run applications being made available. So you're sort of seeing it, how shall I put it? You're seeing the system level or general processing unit functionality sort of move into the embedded space. But you're also seeing things like the fact that, Zephyr, which is, designed for MCUs, was started designed for MCUs. We've gotten ports to the 8 cores for ARM there. We've got 64-bit ports for, various 64-bit for RISC-V and, ARM and x86 and so forth. So we're seeing the Zephyr OS expand up to meet to some degree, but you can still just constrain it to what you actually need. And you have a much smaller footprint. So we're seeing flexibility happening from both directions. And that is where it's getting quite interesting to watch.
The traditional embedded operating system, commercial embedded operating system, dried up. They've been acquired and they've been integrated largely into stacks for bigger companies or, somebody else's use case. Does that mean that, there's really not much left in terms of value? Has the embedded operating system become the part of the plumbing? It used to be that the embedded operating system was like, oh yeah, this is going to differentiate us in one way or another. But is that the case anymore?
Well, actually, at the end of the day, people want to use computing to do functionality. And a lot of the acquisitions and so forth have been aligned with various cloud stories, I think. We can make that sort of statement. But the thing is, we need something that's neutral to the clouds, the different cloud stories. And so there's a role for us. There's a role for the embedded OS because the functionality isn't going away. And the focus on that criteria is key. In the same way, Zephyr, for instance, that's where my examples are, I'm afraid. We've passed over 1,000 contributors now. There's over 50,000 commits. That is more than any other RTOS out there right now. And we're seeing like between 1 to 2 commits per hour into the repo. Look at the rate of on the commercial ones and their public ones that they have public. They're not having anywhere near that level of change. So a lot of this new functionality is showing up in Zephyr first, in some ways, and that's exciting. There's over 250 boards supported by Zephyr. Right. And if people want to put a board into Zephyr, they just put the pull requests in. They don't have to go through the overhead of working with a commercial organization. So having that vendor neutrality is starting to really play off from Zephyr's strengths. And, Linux, when Linux started, and I was around then, looking at it from the sidelines initially, but now, was participating back in the 90s. But, Linux there was a whole bunch of different, vendor specific OSs when Linux started. And this was just a good second solution. And it had the vendor neutrality so that the technical changes could emerge. And I think Zephyr is working the same way. There's other community projects too that are out there and are sort of vendor neutral, and they're doing well as well. They are continuing to get contributions and get input from people. So people are using them, people are extending them, and the new technologies and features are going into them at a faster rate because it's coming in from communities. And there's more people participating than would be in any one company.
Sort of going straight to the commercial element of this, when we saw Linux evolve, eventually people found ways to make money off Linux. So they would offer commercial versions of Linux. Do you see something similar perhaps happening? Maybe this isn't just a timeline, maybe it's a circle, maybe we end up going back to where Linux started with something like Zephyr, where all of a sudden you're like, okay, well, let's commercialize this open source RTOS.
Well, I'd say look at some of our members in Zephyr. They're in there. Wind River and various other ones like Foundries are in there because they see an opportunity to make money off of commercializing it. And there's a demand out there for having these things commercialized. So, I think in some ways having commercial options available makes these community-based products more attractive in the same way they were for Linux. I think Red Hat is being a very clean example of how Linux has become effective by having a commercial option out there. And it certainly didn't hurt Red Hat's market share either. And Red Hat is like, looking at embedded, looking at various embedded, has interest in that space, and you'll see them very active in real-time Linux, as well as, other directions like ELISA and so forth. So we're seeing, these companies look at commercializing some of the RTOSs that are emerging as, a next dimension for growth for them. One of the things we were concerned about when we started Zephyr off is we wanted it to be reasonably resistant to, it just being dominated by one company. We wanted it to be neutral. And so we've been having a lot of focus on that area. And I think if you actually look at the contribution stats from Zephyr for the last year, you'll see it is fairly well distributed at this point. And no one company is particularly dominating it. So in that sense, I think we're sort of trying to follow what Linux established was the best practice, which is, keep the technical decisions separated from, the commercial decisions, and focus on the technical in the community and in the code base. And in both cases, configurability is going to be key. Like, not everyone wants every feature, but only including what's necessary for embedded applications in both Linux and Zephyr is what lets you reduce your attacks, your attack surface and your threat surface, which security is going to be key. These constraints for the embedded application are going to need to take advantage of, because the security considerations aren't going to go away. One of the things I'm sort of looking towards right now for this is that software transparency. You'll see there's a lot of focus emerging on that, and getting the software transparency at the embedded level is going to, I think, be key for us to get the dependability up. Last year, there was IoT cybersecurity bill that came in the US, and the ENISA guidance in Europe on IoT cybersecurity came out, and both were sort of looking and expecting a software bill of materials. And so having this transparency on the software bill of materials and knowing what you're depending on in the OS is going to be key for people being able to trust these things going forward. And you're seeing market pressure now, courtesy of the executive order, that the US government's going to be expecting a software bill of materials. Well, the US government buys a lot of devices where these embedded OSs are necessary. And like medical devices, energy infrastructure, financial infrastructures, all these are places where, you will see a need for having that transparency at the embedded level of what really is you're running on your hardware. That's, it's just that's what we're getting, that transparency there, and making sure we can do that in the embedded space is one of the things that I think we need to see more of going forward, and making sure that these embedded OSs can handle that, and the embedded applications running on top of it can support that is going to be an interesting challenge for us all.
Of course, from a general perspective, yeah, that sounds great. From a practical perspective, you're talking about people who have not done anything near, making their software transparent, maybe ever.
I'd say I've got an existence proof for you that it's possible to do today.
Yeah. Okay.
Okay. Like the latest Zephyr release, the 2.6 release of Zephyr, in the West infrastructure, you can put an option onto your build, and that will generate a software bill of materials for the application you're building using Zephyr that has exactly which files made it into your binary, and has the relationships between the binary and the files. And being able to know exactly which source files made it into your binary enables a true automation to detect vulnerabilities. So like, when Amnesia 33 came out last year, there was some files in FNet that were not in our TIP, but were in our LTS. And we had to go in and manually say, hey, no, we're not using this file. So there's a lot of, at the embedded side, you need to know pretty quickly, are you potentially vulnerable or not, with the image you've got out there. And being able to have that traceability down to the file level lets you, quite frankly, lets automation be able to detect these types of things. So getting more of this type of automation and this transparency into the whole supply chain is really going to be key for improving the dependability and reliability of using the embedded going forward.
And once you start making everything transparent, then you really need to make sure that you're doing your due diligence on security, vulnerability, safety, to your point earlier, all of those things. And I know that those are all areas that you've been working on.
Yeah, and with the ELISA project right now at the Linux Foundation, we're looking at Linux and what processes do we need to do to improve the transparency of and the analysis of using Linux in these embedded applications, so we can get to that level too. But an embedded RTOS like Zephyr has got the pieces are in place today, and we're working on moving them and making sure that from some of the best practices of the embedded, we're trying to take them into Linux as well. And Elisa's looking at what sort of config options, what sort of trace analysis, what sort of processes should be done to get the right level of information surfaced for the whole dependability aspects.
You can find out more about the Enabling Linux in Safety Applications project, or ELISA, at elisa.tech. Next, Assistant Editor Taryn Engmark reveals how BrakTooth leaves doors open for malicious code to crash Bluetooth-connected devices. IoT devices are everywhere, including most people's pockets, workspaces, and living rooms. So hackers invading networks to steal data or hijack electronic devices is a common and justifiable fear. We have all come to expect that a cheap IP camera could be compromised, but a recent announcement has revealed that even our wireless speakers, smartwatches, and other Bluetooth-enabled devices aren't safe. Researchers at the Singapore University of Technology and Design, or SUTD, recently discovered a suite of vulnerabilities present in at least 1,400 Bluetooth-enabled SoC devices from Intel, Qualcomm, Espressif Systems, and other vendors, and it's likely that there are many, many more. The researchers dubbed this family of exploitable vulnerabilities as BrakTooth, Brak being the Norwegian term for crash. BrakTooth vulnerabilities are flaws in the Link Management Protocol, or LMP, firmware of Bluetooth SoCs that can be used to send malicious code that crashes devices. There are a number of ways attackers or malware could leverage BrakTooth. Let's go over a couple of them. One way BrakTooth can compromise a Bluetooth device is a denial of service, or DOS attack. Over this attack vector, a hacker sends specially crafted packets to the target device via its Bluetooth connection. Not being configured to accept these packets, the Bluetooth device firmware accepts the packets but is not able to process them. Eventually, this overwhelms the device's Bluetooth links and crashes the system. Hackers could also use BrakTooth to send packets that will lock an audio device through feature flooding. The researchers at SUTD performed this test on two different audio devices, a JBL Tune 500BT headphone set, and a Xiaomi MDZ-36-DB speaker. The speaker completely froze while the headphones shut down, requiring a manual reboot. Another way it can impact IoT devices is arbitrary code execution. Unfortunately, there isn't currently much that can be done to protect your devices from a BrakTooth attack, other than disabling Bluetooth when it's not being used. But all is not lost. The researchers who found BrakTooth notified device manufacturers of their findings so steps could be taken to patch the vulnerabilities. So if you're a Bluetooth user, which you most likely are, stay on the lookout for device updates as they will likely include manufacturer patches. But from an engineering perspective, BrakTooth raises larger testing-related issues. First, the Bluetooth core specification contains some gaps in terms of test methods, as it states, a Bluetooth device in test mode shall ignore all LMP commands not related to control of the test mode. Many Bluetooth manufacturers therefore likely overlooked the possibility of the LMP being compromised at all. Still, the onus of connected device security doesn't fall to the Bluetooth Special Interest Group. It falls to the solution provider. And even in 2021, it appears that there is either a lack or insufficient knowledge of over-the-air testing tools that could have prevented this bug. That, or time-to-market pressures are so great that testing is simply not thorough enough. In the meantime, the Cybersecurity and Infrastructure Security Agency released a BrakTooth proof-of-concept tool on GitHub that can be used to test Bluetooth devices for BrakTooth vulnerabilities. If you're interested in learning more about BrakTooth, SUTD researchers have launched a microsite detailing their findings at https://asset-group.github.io/disclosures/BrakTooth.
Thanks for listening to this edition of Embedded Insiders. For daily news, videos, and podcasts, visit our website, embeddedcomputing.com.